Hi P5, welcome back. Okay, let's look at question 31. Okay, this is your respiratory system, like I tell you. Okay, so let's just gonna identify all the parts first. So this is your nose. Okay, actually your mouth also help with the intake of air. Okay, so this is your lungs. This is your windpipe. Okay, this eye. Okay, sorry. And this is the inside is actually your SX. Okay, this is your diaphragm. Okay, diaphragm you don't have to know how to spell, because you won't be required to know how to spell them in primary school, but you must at least know their function. Okay, simply put, diaphragm is a muscle that helps you breathe. Okay, so I have all the items. Okay, spelling must be correct. What's the function? Part one is your lungs lah. Okay, so this one is based on your memory already. You should have memorized the function of all your organs in your body. Okay, at least the primary school syllabus one. Okay, you must, because they may ask you anytime. So let's see. Okay, so okay, sorry, don't write lungs, write whatever they give you. So just say part Y allow the air sacs to exchange gases with the blood vessels. Okay, so that's the function. Okay, so actually the one that do the exchange is the air sacs inside which is inside your lungs. Okay, and then your air sacs is actually wrapped around by blood vessels. So these blood vessels, right, they'll go and take the oxygen from the air sacs, then return the carbon dioxide to the air sacs. Then your air sacs, what they'll do is they'll bring it out, okay, and then pass out the windpipe, and then you breathe out through the nose and your mouth. Okay. Okay. Question is asking you which activity is showing that Peter is resting. Okay, a resting heart rate is a heart rate that when it's the lowest. Okay, that means it should not fluctuate. That means it shouldn't increase. Okay, your heart rate will increase when you do certain activities. The more strenuous, that means the more tiring the activity, the higher the heart rate. So resting heart rate should be low and should not increase. Okay, so the one that doesn't change is Z. Okay, average adult heart rate is about 60 beats per minute. Okay, in case you ask, you just in case during exam they ask, how do you remember this? You just have to know that about 1 second 1 beat. So 1 minute has 60 beats, right? Sorry, 1 minute has 60 seconds, right? So therefore 1 minute should have 60 beats on average lah. But of course it depends from person to person. There can be people with lower heartbeat than people with higher heartbeat. Usually the healthier person will have a lesser heartbeat, because the healthier person will have a stronger heart. The stronger heart is able to pump the blood around the body with one pump. Okay, whereas an unhealthy person, the heartbeat usually be more, because the heart is weak, okay, or their body has a lot of fat, so it's very hard for the blood to move. So the heart has to has to pump more. Okay, so a healthy person generally has a lower heartbeat, lesser heartbeat. Okay, so which activity is the most vigorous? Vigorous meaning tiring, okay. So as I was telling you, the more strenuous your activity, the more vigorous, the more tiring, the heartbeat will be faster, because when you do, for example, you do exercise, your body will need more energy. To be able to produce more energy, every part of the part of your body that is working has to have more digested food and oxygen to convert to energy. So this digested food and oxygen must go to your cells faster, and your blood doesn't move by itself, so the heart has to pump faster to bring them to your cells. Okay, so let's write right now. So obviously we can see that the heart rate for activity X is the highest, so it's activity X. Okay, then they ask you to explain, right? Okay, vigorous activity requires more energy. Stop. The heart have to pump faster so that the blood can transport just bring this down. Okay, so you mentioned activity X. You mentioned that the heart need to pump faster to transport this digested food and oxygen. Oh, so these are the key things. Okay, question A they have already done for you. Okay, the one that helps the plants exchange gases is the stomata lah. Okay, stomata is basically found on all leaves, so you just have to label any leaves. Just for additional information, so if you zoom in enough, you can actually realize that stomata is something a bit circular. Oh, yeah, a bit like this. You can actually Google it, go and see it. Oh, so they have tiny openings here. It's like a mini mouth. So the mouth can actually close, this stomata, which is like a mini mouth, can close and open. Okay, when it open, it can take in more gas. When it close, it will take in less gas. Okay, but the bad thing about stomata is because it is a gap, right? So the water vapor can actually escape through the stomata. So that's the disadvantages of stomata lah. But it's still very important because it allows the plants to take in oxygen, take in carbon dioxide, and also to give out oxygen and carbon dioxide. Okay, question B tells you that it's kept in a black box, so this is where the light comes from. The hole is where the source of light is. Okay, so it rotates. Okay, so it rotates very slowly, but it just rotates. Now, if this rotating disc does not rotate, right? Naturally, the leaf will grow towards the hole because plants respond to changes, right? You learned this in P3, so they'll grow towards the light. However, because this thing is rotating, so every part of the leaf will have enough light, so it doesn't have to grow towards the hole because the light is equally distributed. So you will not expect it to grow towards the hole. Okay, you just go straight. So it's this one. Okay, this questions tells you that there are more bubbles produced on the lower surface. Okay, reason is very simple. Let's think about just a normal plant. Okay, so if I have a normal plant, right? Okay, I'm just gonna draw one leaf lah. Okay, whatever you are seeing now is the top part. The bottom part is below. Okay, because I can't really draw 3D diagram here lah. Now plants are quite smart. Okay, evolutionary wise, they know that they will lose water vapor. So because of that, they grow lesser stomata on the surface. Okay, why they do that? Because the top part is facing the light, right? Okay, when it's facing the light, the stomata will open up. When the stomata open up, they will release more water vapor, meaning they'll lose more water. Okay, maybe let me just write it down so it's clearer for you to see. Okay, the top part is facing the light, right? So more light, and also because the sun produces heat, so not only there's more light, there's also more heat. This will cause the stomata to open up. Okay, and therefore water loss will be faster. Also because there's a higher temperature, more water will be lost, so there'll be more water loss. This is not what the plants want. The main purpose of the plants is not to release stomata. The main purpose of the stomata is not to release water vapor. The main purpose of the stomata is to exchange gas, not to release water vapor. Okay, it's just like us. We don't actually want to lose a lot of water because that's dehydrating for us. So the plants are very smart. They know that they need stomata. They cannot live without no stomata. But they also know that they don't want the stomata to lose water vapor. So they grow on the bottom mostly. Okay. When you grow on the bottom mostly, there will be less light, right, and less heat, right? Therefore, there will also be less water loss. So that's the reason why most stomata is found on the underside of the leaf. The top part of the leaf will still have stomata, but lesser stomata. Most of the stomata, you must remember, is found on the bottom part of the leaf. But you don't have to worry. They will not ask you. Usually, they will not ask you. At least from P3 to P5, they will not ask you why is stomata mostly found on the bottom. Okay, maybe when you go to P6, when you learn about adaptations, there's a chance that it may come out for exam, because stomata growing on the underside of the leaf is a structural adaptation. Okay, but you don't have to know this word structural adaptation yet lah, not in P5. Okay, but at least at P5 you must know most of the stomata is actually found on the underside of the leaf. Okay, so since most of the stomata is found on the underside of the leaf, the lower surface, therefore they will also release more water vapor, they release more gas, therefore there will be more bubbles. Bubbles are formed because of gas. Understand? So actually the explanation is very simple lah. It's just that I talk so much so that you can understand in depth why that is so. Okay, so you can just say because the stomata can release gas, so that's why more gas means more bubbles. Okay, let's look at question B. Before I can talk about this question, I think there may be something wrong with the graph. Let's go and look at it. Okay, they are talking about the water left in the container, right? Okay. Now, this is the water they are talking about that's left in the container. I mean, obviously at first there will be more water, at the end there will be less water. The water level should decrease because the roots will take up water, right? So there should be a lot of water at first, very little water at the end. Okay, but then if you look at the graph, okay, this is 0 lah, obviously. So I don't know, I can plant the minute. So how long did he put in the okay, this is 2 hours mark, okay, because they say 2 hours mark. Okay, so at first there's no water in the container, okay, in the setup, which doesn't make sense because at first obviously there's water. It's just that after some time the water level drop. Okay, but if you look at the graph, the water level is increasing. I would think your line should go like this, because at first there's some water, then as time passes there's lesser and lesser water left. Okay, I mean, yeah, that's what I think. So, but never mind. We'll use partial part of the graph to answer this question. I think what this question is trying to tell you is this. Let's ignore the graph altogether. Let's just look at this. Let's just say that at the end, don't care about the graph already, because I think the line is not drawn correctly. I think what they're trying to tell you is P at the end has more water left. That's why it's the highest, highest amount of water left. So what they're trying to tell you is P has more water left. Q has average, I'll just say average amount of water left. Then R has the least amount of water left. Okay. Now, if that's what they are trying to tell you, then what they are also trying to tell you is this: the plants in P took in very little water, the least amount of water. The plant take in the least amount of water, that's why the water left will be a lot. Whereas R has the least amount of water left, right? That means this plant take in a lot of water, or I'll say most amount of water. Okay, so that's what the graph is trying to tell you. So now we have to relate the question back to the diagram. Now, like what I always tell my students, if you are not sure what they're asking, because I understand this question is quite lengthy and it may be a bit confusing, okay, and they may not know what the question is, what concept they're talking about. Usually, if it's under the same question, okay, for example, both of them, A and B is both under question 33, right? 33A and B is talking about, sorry, 34A is talking about stomata, right? So 34B is also likely to be talking about stomata. Okay, most of the time, same question should be testing the same concept one. Okay, so that will give you a clue of what they are talking about. Anyway, let's go back to this. So let's look at the question now. Okay. Okay, so now let's look at the question now. They tell you the plants give out water vapor, right? Okay, that's natural. Now, actually there's a relationship between the amount of water they give out and the amount of water they take in. Okay, it's just like for human beings. When you go for a PE, your teacher will always ask you to drink up, right? Why your teacher will always ask you to drink up when you go for PE lessons? Is because you will sweat, your body will lose water, to replenish the water loss, you must drink more water. So it's the same for plants. Okay, when they give out more water vapor, okay, when they give out more, that will also mean they need to take in more water to replace the water loss. They want to take in more water. Okay, so let's go back to this page. They are asking you based on the information, okay, which plants, okay, from question A and B lah, which plants lose the least amount of water? Okay, so obviously, if my understanding of what the question is trying to ask based on the graph is correct, then the plants that lose the least amount of water is this one lah. Right not? Because you have the most amount of water left in the container, that means the roots take in very little water. If the roots take in very little water, that means there's very little water lost. Okay, so let me just type that down first. Okay, after me, I mean this is a bit complicated because of the fact that the graph is wrong already. So plant P lose the least amount water. Okay, but they ask you to explain why. Why did it lose the least amount of water? Now let's look back at the question. Okay, now what's so special about P is this? Okay, naturally R should lose the most amount of water. Why? Because totally no oil cover rate. If no oil cover rate, that means both sides of the leaf stomata is open. That means both sides of the stomata is constantly losing water vapor. Whereas for Q, right, only the upper surface is covered. Whereas for P, only the lower surface is covered. Okay, and if you go back to the top part just now, okay, just now we already explored this concept, right? The lower surface of the leaf has more stomata. So since the lower surface of the leaf has more stomata, and you coat the oil on the lower surface of the leaf, that means more stomata will be covered as compared to Q. Top part has lesser stomata, lower surface has more stomata. So if you coat oil on the lower surface, that means more stomata will be covered. When more stomata is covered, there will be much lesser water loss, because the holes that allow the water vapor to escape is mostly covered already. Okay, so now we can explain this clearly already. Okay, I'm sorry, this is a bit confusing, so maybe you have to go back to a few minutes before this to try to understand what I'm saying again, because of the fact that this is a very long question and then there are some errors here. So as I was saying, since P lost the least, based on the graph, we know that P lost the least amount of water, and they ask you why, right? So you can just say most of the stomata are found on the underside of the leaf, which have been covered by a layer of oil. Okay, so since most of the stomata is covered already, there will be less water loss. Okay, just expand this. Okay. Okay, so we have Peter again. He saw some steam while having a hot shower. Observe some steam. Okay, so what is this statement that is wrong? Okay, this is one of the, I would say more than 90% of the students will always have this wrong concept. First, you must know what is steam. Okay, go and think about it. I give you about 3 seconds. Think what is steam. Okay, a lot of people will tell me steam is gas, and you are correct. Steam is indeed gas. But what kind of gas is it? Steam comes from water, right? So it is a water vapor. So now the question to you is, water vapor is called water vapor. Steam is also called water vapor. So what's the difference between steam and water vapor? The answer is there's no difference. The only difference is steam is also water vapor, but steam is water vapor at 100 degrees Celsius, meaning the boiling point of water already, the maximum temperature. So steam is actually water vapor, but water vapor can refer to any water in gaseous state, but for steam it is only water vapor that is 100 degrees Celsius. Now, right now, wherever you are, right now there are a lot of water vapor around you, but if you look around you now, you can't see them. So this tells us something. Water vapor cannot be seen. So I was telling you steam is a water vapor, right? So if steam is a water vapor and water vapor cannot be seen, then Peter should not have claimed that he see the steam, because you are not supposed to be able to see steam. Okay? So let's go and write this down. I seldom see this question come out, but I would say really more than 90% of students will not know, even for PSLE students, will not know that steam is actually water vapor and steam cannot be seen. Okay, I would think largely is because of our fault, adults, because we use this word steam very loosely. Okay, whenever you see smoke coming out from hot water, okay, like your boiling kettle, you'll say, hey, there's a steam, there's steam. Okay, no, it's actually not steam because you cannot see steam. So let's write this down. Okay, steam is water vapor and water vapor cannot be seen. Okay, he didn't dry himself. Okay, so before I go on to question B, let me just explain to you what you're actually seeing. So you know, sometimes when you boil soup or you boil water, you can see some smoke coming out, right? Those are not actually steam, those are actually clouds. Okay, I mean, if you have learned water cycle, you should know that clouds is not gas. What cloud is actually liquid. Or if you look out of your window, if you can see clouds, clouds is actually liquid, because like I say, water vapor cannot be seen. So if you can see clouds, clouds is not water vapor. So what are they? They are, like I say, they are clouds. Okay, they are just that, it's just that they are water vapor coming out from wherever they come from, but right now they are condensing because they lose heat to the surrounding. So when water vapor lose heat, it condenses. That's why they become liquid, and that's why you can see them. Okay, so anyway, let's go to question B. Peter, he didn't drive himself. He stepped out of his bathroom and in his wet body. That means his body is wet. That means there's a lot of water on his body, or to be more precise, water droplets. And then he feel cold. Okay. Now, if you watch the video on heat and temperature, you should know that our body is actually a poor tool to measure temperature. You feel cold doesn't mean it's cold. You feel hot doesn't mean it's hot. Okay, a simple example is when you have fever. When you have fever, you feel wow so cold, but actually when you take a thermometer to measure your temperature is very high, yet you feel cold. So our body is actually a poor instrument to measure temperature. So although he feel cold, that doesn't mean the surrounding is cold. Okay, I mean at home or when you go to a hotel especially, after you take a shower you come out you realize it's very cold, but actually the temperature of the hotel room or your house is still the same. The temperature didn't change, but yet why do you feel cold after you take a shower? Okay, now the problem lies with the word wet body. Like I say, wet body means there's water on his body. Okay, now so let's go and answer. While answering you understand. Okay, the water on his body, sorry, no typo, body gain heat from his body when evaporating, causing his body to lose heat. Okay, so the water droplets on his body will want to evaporate, right? And in order for evaporation to take place, they need to gain heat. So where did the water droplets on his body gain heat from? Gain heat from his body. That means his body lose heat. When his body lose heat, he will feel cold. Okay, our body feels cold when we lose heat, not because the environment is cold. Peter felt cooler when he stepped into the windy balcony with his wet body. Okay, now this one you must first have a basic understanding of the causes of factors that affect evaporation. There are 4 factors that affect evaporation. I'll briefly write them down first. I will not go into detail because you can actually go and watch the water cycle video that I've done because this four factors is actually a very long explanation, but okay, I'll just summarize them. The four factors is temperature. You must have this at your fingertips. Wind, humidity, and temperature, wind, humidity, and exposed surface area. Okay. Now, humidity and wind is actually related one. Okay, later I'll explain to you briefly so you know why. So he stepped on a windy balcony. Now what wind do is, wind will blow away water vapor. Or in case you do not know, humidity is not how hot a place is. Humidity is the amount of water vapor there is in the surrounding. So the wind will blow away water vapor. When you blow away water vapor, you decrease humidity. When you decrease humidity, the lower the humidity, the faster the evaporation. Okay, so the faster the evaporation, for Peter case, because the water on his body evaporate faster, his body lose heat faster lah. Oh, that's why I mean, if you are caught in the rain, okay, and you run into a shopping mall, it is a very bad idea. Okay, you will fall sick. It is actually very logical, because if you are caught in the rain, your body will be soaking wet. You run in the shopping mall, because air conditioned area have lower humidity, right? There will be lower humidity and aircon has wind. Okay, so the water on your body will start evaporating. That means your body will lose heat very quickly to the water that's evaporating. That means your body temperature will drop very quickly. And when your body temperature drop too much, right, you will fall sick and you catch a cold. Okay, so that's why every time you are soaking wet, try not to go into air conditioned area lah. Okay, because air conditioned area has low humidity and they also have wind, which will increase the rate of evaporation. Anyway, let's get to this. It's a bit far-fetched already. They ask you why you feel colder, right? Okay, the wind reduces the humidity, which increase the rate of evaporation. His body loses heat faster due to the evaporation. Okay, so like I say, okay, yeah, so this is the explanation. Okay, I repeat again, I summarize it. The wind will decrease the humidity. When the humidity is lower, evaporation is faster. That means the water droplets on his body will gain heat and evaporate faster. That means his body will lose heat faster. That's why he will feel even colder. Okay, let's go next question. Okay, let's look at 36. 36 is a heat and temperature topic. You don't really have to look at the diagram. Okay, they tell you that for setup 1, the temperature increased by 2 degrees Celsius. For setup 2, the temperature increased by 10 degrees Celsius. So setup 1 is actually air filled. Setup 2 is actually sand, mostly sand. Okay, so the question is asking you how the temperature in the substance of the bottle change when you compare setup 1 to setup 2. Okay, so obviously, just by looking what I just wrote down, right, the temperature in setup 2 rises faster. Okay, when the temperature increase or decrease faster, right, that means it fluctuates more easily. That means it is a better conductor of heat. Okay, so let's go and write it down. Okay, so because the sand temperature rises faster, therefore I can conclude that the sand is a better conductor of heat than air. Something seems a bit wrong. Okay. Okay, now let's go. So before I continue, I'll just conclude this is a poorer conductor of heat. It's better conductor. Oh. So anyway, generally you should have known this, like air is a poor conductor of heat. That's why animals with thick fur is able to survive in very cold, low temperature, like for example a polar bear lah. Or it's not because the polar bear, it's not because of the fur of the polar bear that keeps the polar bear warm. It's because the fur traps a lot of air in the polar bear, and air is a poor conductor of heat. That's why the polar bear won't feel cold so easily. Okay, so now Ben's uncle, he wants to deliver live fish to his customer, and one of the criteria is that the temperature should be maintained. That means the temperature should try not to change as much as possible. Okay, so if you look back, okay, if you don't want the temperature to change so much, obviously you choose this setup, right? Temperature only increase by 2 as compared to the other one, which increases by 10. So the substance that you prefer is air. Okay, they ask you sand or air, and you know air is a poorer conductor of heat as compared to sand. So let's go write this down. Air, stop. It is a poorer conductor of heat. Okay. Therefore, the text. Okay, for question 37, it seems very complicated, but it is actually not complicated. If you have watched the electricity video that I've done, you realize that actually, don't go and care about the no. You just have to focus on the yes. Yes, yes, yes. Why? Because yes, that means the light bulb light up, right? If the light bulb light up, that means somehow, regardless it's directly or indirectly, it is connected. So what you can conclude is that you have P, Q, T, these three are connected. So P, Q, and T are connected. The rest R and S is not connected. P, Q, and T can be connected directly or indirectly, we don't know. Okay, but at least they are somehow connected. Okay, basically they are connected. Circuit card is a topic that a lot of students overthink. Actually, it's very simple only. Okay, they want you to draw two lines in the diagram, right, to show how the wire will connected to the circuit tester. Okay, they already connect P and Q to you. So there are actually a few ways to do it. Okay, at the end of the day, you just have to make sure that this P and Q which is connected to T, because like I said, they are connected. So you can either connect P to T or connect Q to T. Okay, it's up to you. Okay, basically R and S is not connected to the rest. So I'm just gonna draw. Sorry, okay, yeah. So it's very straightforward. Okay, again, electricity because it's on the same topic. Okay, so like what I usually do, I have a habit of counting each battery as 2 units. So 2 units, right? 2 units, 2 units, 2 units. So this is total 4 units, 4 units, and this one is total 2 units. I don't need to write anything. In a series circuit, the electricity is shared, so these 4 units split up among these two bulbs, so it becomes 2 units bright, 2 units bright. Okay. Also, sometimes there will be trick question. So just make sure they are connected properly. Okay. So the poles, the negative must be connected to positive. Okay. For the battery. Then this one not shared, right? So 4 unit. This one even worse. 2 units being shared by 2 bulbs. So 1 unit, 1 unit. Okay. Now they want you to arrange from the increasing order of brightness. That means from the least bright, right? So as you can see, C is only 1 unit bright. Okay. A is 2 unit bright, and then the brightest is obviously B 4 unit bright. 2 is increased. So they want you to increase the brightness of C, but you don't want to change the number of battery. So the number of battery must remain as 1. Okay. So there are 2 ways. Okay, as long as you don't change the battery, they are fine with it. So the first way is let me just type it out. Okay, remove one bulb. Now if you remove one bulb, they don't need to share what. So from 1 unit bright, you become 2 unit bright. That's the first method, which is the confirm you should get it right one. So simple. The second one, you just change the connection. Okay. Manage the circuit in parallel. Okay, why? Because parallel circuit they don't share. I'll just briefly draw it. So this is the brightness. This is a battery. So now I'm just gonna draw a symbol. The battery by right also I should draw symbol. If they ask me to draw a circuit during exam. So 2 units, right? But like I say parallel circuit do not share electricity one. So it's still 2 units, 2 units. So it's indeed brighter than originally this ready. Okay, so that's our 2 ways. Okay, let's look at question 38. Okay, so basically what they're telling you is they put a this here. Okay, then the this will roll down. Okay, then they are telling you that this y roll faster, this x roll slower. So that means something must have happened to this x causing it to slow down. Okay, so probably this x is a magnetic material, so it's being attracted by the magnet. Okay, that's why it slow down the speed. Okay, so you can write that down. Okay. Okay, then now he roll aluminium. This. Now aluminium is a metal, but you must always remember most metal are non-magnetic. So things like gold, silver, aluminum, copper, bronze, all these are non-magnetic material. The commonly tested magnetic material is your steel and iron. Okay, so anyway, because it's non-magnetic, right? So you expect them to be no attraction from the magnet, therefore it should roll down faster. Okay, so let's write that down. Okay, that's all for today. Thank you.